Good evening, everybody. Thank you very much for joining us this evening. I'm going to talk a little bit about Jotun, just a brief introduction. Then we'll talk about fire protection, intumescent coatings, fire testing, HB over A, fire, value engineering, standards of finish, and a little bit about CPD education. Jotun are a global company established in Norway in 1926. We produce around about 832 million litres of paint a year, distributed over 45 countries, $1.9 billion a year turnover, and we employ just under 10,000 people working from 40 factories around the globe. We're well represented in the Middle East and Africa region. And briefly, we started off in the Middle East in 1962 with a factory in Libya, and we've slowly progressed. In Saudi, you'll see that we started in 1984. So we've got a long history of working in the Middle East. We've got a central lab in Norway, and then we've got labs in Dubai, Malaysia, China, Korea, India, and Turkey. This enables us to globalize the coatings, so we're supplying the same coating globally. And we're one of the few companies that offer a single source solution on infrastructure projects. We do steel protection for anti-corrosion, decorative coatings, fire protection, concrete protection, floor coating, and powder coatings. So we can offer a full solution to any building project. So, fire protection of steel structures. What is the purpose of fire protection? Why do we need fire protection? The main purpose of fire protection, the primary functions are to delay the building collapse, extend the search and rescue time, and preserve the life of the people in the building. The secondary function of fire protection is protect structure and inventory and prevent a catastrophic failure of the building. There's many different types of fire protection systems. There's active systems, passive systems, and reactive systems. If we look at active systems tend to be the sprinklers or halogen systems that are fitted, and they're the first line of defense in a fire. Passive systems can be vermiculite spray, cementitious spray, fireboards, or mineral wool. Cementitious and vermiculite spray is the most popular used in the Middle East, and these are used behind linings. Very effective and very easy to apply and relatively cheap, but unfortunately very ugly. So if the steel's exposed, we tend to use intumescent coatings. And then we have reactive systems, which are thin film intumescent for either cellulosic fires or epoxy intumescents for hydrocarbon fires. Today, we'll just be focusing on thin film intumescent for cellulosic fires. A cellulosic fire is one that you would see in everyday buildings. In the office you're probably sat in today, shopping malls, airports, these are cellulosic fires. A hydrocarbon fire is a fire that takes place on an oil refinery or offshore oil rig. And today we're going to talk about fire protection using thin film intumescent coatings. What is an intumescent coating? The word intumesce is a French word and it means to swell. It means the coating will swell and provide insulation to the steel and prevent the temperature rising in the steel. If we look at this short video, we see a painted panel. This is speeded up, and in the fire, the coating swells, and that swelling is actually offering insulation to the steel. Another short video. This was taken from our furnace where we do the fire testing, and you can see the initial reaction is it blisters and pops, and then it starts swelling, and this is acting as an insulation material. It's stopping the temperature of the steel rising. After the coating's finished, we're left with something called a carbon char. This is what it looks like after the fire. And these products are used extensively where you've got steel exposed as an architectural feature. Airports, shopping malls, train stations, they tend to leave the steel exposed. And this is where we'd use these products. If we look at steel, its strength factor starts to reduce at a temperature of around about 550 degrees C. This is called the critical core temperature. So steel at 550 degrees C has lost nearly 50% of its structural strength. And when it loses its strength, this is what happens. This is unprotected steel in a building in Madrid, and it will collapse. And obviously anybody in the building will be severely injured or killed. When we apply an intermittent coating, if you look at the yellow line on the bottom, the left-hand side axis is temperature, the lower axis is time. If you look after 10 minutes, you can clearly see here, the steel has reached 550 degrees C after around about 15 minutes. This is the failure temperature. The red line is the furnace temperature, and it closely follows. That's unprotected steel, the red line, and this is temperature. If we apply an intermittent coating, as you can see, this yellow line, it starts to swell here, and then after 70 minutes, it's given 70 minutes fire protection. So that's the swelling action. It's stopping the temperature rising. And who decides fire protection time? Well, you, the consultants, and the fire engineers decide the fire protection time. And in general terms, what you tend to do is look at the building, its occupancy, its height, determine the risk profile, and then give a fire protection period. And generally, the building codes used are BS 999, Document B, or NFPA 5000. These are documents that will give you these type of tables, which will tell you it's an office building, it's got sprinklers, and it's more than 30 meters high, so it requires 120 minutes fire protection time. What do we do in Jotun? We also look at the same documents that you look at. We design fire protection coatings to cover the fire protection times. We've got a research and development lab over in the UK, which just recently opened. And in that lab, we have R&D furnaces. These furnaces basically will accept 1 meter high, 1.8 meter high columns and beams, and we can do third-party testing. If you look on the far left-hand side, this is coated steel that's put into the furnace. The middle photo is the furnace acting. You can see the bright red wires. These are thermocouples which are measuring the steel temperature, and the one on the right-hand side that's hanging down is measuring the furnace temperature. And then when the fire test is completed, you can see on the far right side, you can see the two columns where the paint is intermessed and insulated the steel for a given period of time. Once we're happy that the coating works for a given fire resistance, we then take it to a third-party furnace. You can see it's a much bigger furnace, and the testing is done by a third party. Once that third party are happy that our product performs the way we say it is, they will issue a certificate. The third-party labs around the world are BRE, Warrington, and UL. They tend to be the most popular labs, and they test to BS 476 or UL, which is the American standard. Once we've done the fire testing and we've got third-party certification, we usually also have to go to local approval level with the local fire department to get the products approved. So these products are very, very well policed by the local civil defence and by third party. When installed correctly, they work extremely well. We talked earlier on about asset protection. This is a typical asset protection. There was a fire in this building on the 8th floor, and it was contained to the 8th floor. And if you look at the right-hand side photo, you can see the columns are still stood and there's no problem. This building will be refurbished and put back into service. If there was no fire protection, the building would have been a total loss. This is one taken in your home. This is a shopping mall behind this tower in Riyadh. I'm sure you know which tower it is. And there was a fire you can see there. And we managed to get some photos after the fire. And it's interesting, you can see the columns have blistered. The products worked in a textbook way. But more interestingly, if you look up in there, you can see the trapezoidal decking has buckled and collapsed as the concrete has broken on the floor above. But if you look at the beam is still showing in very good condition. The steel that's bent and warped is the secondary steel, which was probably holding the ceiling up, the false ceiling. So the products have worked absolutely perfectly, and the building could go back into service reasonably quickly. One thing we're often asked by a lot of people is, can you give a cost per square meter? It's very difficult to do this, the reason being that steel section sizes are very different. And how do we establish the thickness of the coating? We have something called a section factor, which is the heated perimeter, which if we look, it's the red area, divided by the cross-sectional area, which is the grey area. And this is called the section factor, the HP over A. If we imagine the left-hand side piece of steel, it's a very thick piece of steel. It would take a lot more energy to heat the steel to 550 degrees C. So we need less paint because the steel absorbs the fire. On a thin piece of steel, we need more paint to insulate. And if you look there, this is a typical beam. This is a 75 HP over A. It's a nice, thick, heavy beam. And the right-hand side one is a very light beam that's probably used on a roof section, I would think. And it's 300 HP over A. So we need much thicker intermittent coating on the thinner steel. And if you look, this shows the HP over A. The yellow line is HP over A 264, which is light section, and you can see it heats up very quickly. Whereas the green line is a HPA 61, and it heats a lot more slowly. We also have a situation where if you have a concrete slab on top of a beam, only 3 sides are exposed to the heat, so it heats more slowly. So the main information we need as a manufacturer is the section sizes and the sides exposed. We can then look at the HPA factor. If you look on the left-hand side of this table, you can see section factor up to M4, which is the HP over A. And once we have the HP over A, we can work out the exact thickness of the coating. I'm just going to talk very briefly about fire protection, fire engineering. These are very expensive coatings, but if we engage early with the clients and yourselves, we can look at different types of fire engineering and value engineering to reduce the cost. Just a few examples. When we look at the fire protection, the PFP is about 10 to 15% of the project. If you look at this particular breakdown, the steel itself is 30%. So the fire protection is nearly half the cost of the steel. So looking for cost savings are very important. The way we do this, if we look here, we've got a section factor of HP over A 220. If we increase the failure temperature, we can actually reduce the volume of paint required. We drop the thickness from 3.2 millimeter to 1.9 millimeter. But to do this, we need to engage a structural engineer. Be very careful if you're offered a failure temperature above 550, which is standard, if it's not been value engineered by a structural engineer. But where we can do without a structural engineer, if we look at this rectangular hollow section, it's a 200 by 100 by 5 millimeter, it's HPA of 10, and it needs 5.3 millimeters of coatings. But if we increase the steel size, the wall thickness from 5 to 10 millimeter, we've reduced the paint required by nearly 50%. We've gone down from 5.3 millimeters to 2.7 millimeters. It's a huge reduction in thickness, but also a reduction in application cost and time. Now, I understand that we've increased the steel thickness and the cost, but there's balance sometimes where we can actually use value engineering to decrease the DFT and the time required to coat it. So value engineering is very important. This is some software. We have our own little software we use for value engineering, which we can share with anybody. One other thing we do is we can mark up drawings on any project. These can be used during the project, and after the project can be handed to civil defence. Just briefly, we'll talk about coating systems. In an intermittent coating system, you have a primer, you have the intermittent coating, and you have a top coat. The primer protects against corrosion, the intermittent protects against fire, and the top coat provides colour and protects the intermittent. And that's what it looks like: your primer, your intermittent coating, which is usually white, and your top coat. On the primer systems, we accept that steel is sometimes fabricated overseas, so we just say make sure it's a good quality epoxy primer. But on the top coat, it's important for specifiers out there that you specify the same top coat intermittent. On the left-hand side, you can see a piece of steel which is the same primer and intermittent. The right-hand side is the same primer and intermittent supplier, and it's a nice even char. If we look on the middle, you can see areas where the paint has not swelled, it's not expanded. And this is because it's not worked on that particular top coat. The top coat's prevented it. So make sure if you specify, you always do specify the same manufacturer for top coat and intermittent. These systems are lead contribute to lead 4 and give 2 potential credits. And we've got fire protection systems between 30 and 180 minutes that are lead V4. Generally, these products are applied on site. It's a trend, certainly in Europe, to have them applied off site, but in the Middle East, because we've got reasonably good weather, we can apply them on site. One of the problems you can get with these, because of on-site application, is poor cosmetic finish. Again, for the specifiers, we recommend that you are careful when you specify. There is something called an ASFP, Association of Fire Protection, and they issue a document on the standards of cosmetic finish, which talk about a basic finish, a decorative finish, and a bespoke finish. It's always good to have in your specification these different standards of finish, so everybody knows and understands. And we always recommend on-site mock-ups prior to commencement of the project, the fireproofing project. These are two shots of intermittent coatings applied and applied badly. The right-hand side one is always left as a little bit misunderstood as how somebody could walk up a column, but the left-hand side one is showing intermittent paint which has been very badly damaged by other trades. So understanding the right cosmetic finishes is very important. On-site technical service, we have fully trained guys. If you look at the left-hand side there, what's happened is the column's been erected and then they've built a wall, so the fire protection can't be applied behind it. Good quality technical service always helps and can save money. Our guys in Jotun are SSPC, NACE or FOSIO approved. We've also written some NBS and CSI format specifications, which we will give to anybody who wants them. And these specifications use the best and latest terminology in the specification. And as of today, we do CPD training, and we've got courses available in this one. If anybody needs a certificate for this, we can issue a certificate from REBA. We've also got various other CPDs that we can offer directly. Just very briefly, we said we'd give you a little bit of an insight into what's coming. The latest thing that we are launching in Jotun is metallic shades. We asked architects and consultants what they're looking for, and many came up with these metallic shades as a wish. So we're launching these metallic shades at the moment. There you can see there's a lot of different, from gold, silver, bronze, and aluminium. So to conclude, and thank you very much for your attention, intermittent coatings rely on complex chemistry that requires third-party testing. There are significant costs, have we seen, up to 15% of the cost. Selecting the right manufacturing product and value-added services can reduce the cost substantially. We saw some examples where up to 50%. If we engage early together with the consultant and the main contractor, we can offer some big savings. And our two products are known as probably the most efficient in the market, with more than 8 million square meters of steel coated since 2009. Where we can help is value engineering. We offer a single source solution. We've got excellent site supervision, and we've worked on most of the big airport and transport systems in the Middle East. Talking about, we've just got a few slides of projects here that we've completed. Riyadh Metro, I know some of you are in from Riyadh, that's coated exclusively with Jotun. Dubai Opera, Cairo International Airport, the terminal there. The midfield terminal at Abu Dhabi, Dubai Metro, Haramain High Speed Railway, Bahrain City Centre, and King Abdullah Financial Centre. Okay, thank you. My colleague now, Mr. Niru, will take over and take you through floor coating. Thank you.
Good evening, everybody, and thank you for welcoming us to this presentation. Our floor coating business is 20 years old, and during this period, we have achieved some significant milestones in terms of number of projects as well as our product portfolio in itself. And floor coating is an integral part of the single source solution and the intermittent concept, infrastructure concept, where intermittent fireproofing is also a part of the whole infrastructure concept. Let's just go through the agenda first. Today we have why concrete protection, what kind of usage areas we have, classification of systems and technology, surface preparation, and what is our policy towards floor coatings and how we run this category. Products and its application. Although we have a significant range, we will today choose a few products that is in current days trends, specifications and market trends, industrial floors, and a few project references. Let me show you some of the esteemed projects that we have been involved with and some of the satisfied customers that we have globally. Some of them are really big, huge conglomerates who have very stringent approval processes. And we can proudly say that we have satisfied most of these customers in some form or the other. Why concrete protection? Because there are, even in today's world, some projects that don't have floor coatings. They believe that they have used some kind of hardeners or used the concrete in such a way that it doesn't require floor coatings. But this is slowly becoming obsolete because no concrete floor, if not protected well, will last you a long period of time. So essentially, concrete floors are protected to prevent any damage from impact, from abrasion, from chemical infiltration. Then the purpose of floor coatings is to make the floor look hygienic, easy to maintain, sanitary, and look aesthetically pleasing for a long period of time. Then by default, also floor coatings prevent the structure itself from deterioration, the concrete structure. And remember one thing, that once a floor gets contaminated or there is any level of contamination that penetrates a normal floor without coating, it's almost impossible to neutralize that contamination totally. These images, I'm sure many of you must have seen from time to time, but you can see here, these are floors that have not been painted for some reason, but the level of contamination that exists on these floors, whatever you may try and remedy, rectify or create a process to clean up these floors and then repaint them, you are never going to be 100%, because these floors over a period of time have absorbed so much of oils, battery fluids, other natural salts, moisture, so that penetrates deep into the concrete. It's almost impossible to make them back to its original level. So you can only come to a level that is acceptable, but it'll never be 100% or perfectly fine with the new coatings. These two images on your left and the right, you can see clearly from the left image, the level of contamination in a factory is so deep that even if you want to remedy this, it will take you a lot of effort, but you will never be 100%. And the picture on the right is also a factory. It's a redone floor, but you can see it's much better than the one on the left, but still you can never be 100%. So contaminated floors is always going to be a big challenge to remedy or to bring it back to top-notch 100%. The other aspect of floor coatings or concrete protection is there's a lot of ingress of corrosive elements like moisture, carbon, and chlorides from the atmosphere. All these react with the substrate, and a naked concrete substrate allows these elements to permeate into the concrete. It is believed that every year a concrete structure that is exposed can lose about 1 millimeter of concrete cover each year. So that means in 10 years time, you lose 10 millimeter of the cover itself. And once the cover is exposed, it starts to attack the rebars, which is below the concrete substrate. So to do some basic repairs, we have 3 products today here. One is a filler, JotaFloor filler, which can repair up to 3 millimeter of the concrete. And then you have JotaFloor filler plus, which can repair from 3 millimeter up to 10 millimeter. And about 10 millimeter, we have JotaFloor slurry, which is a combination of epoxy resin and silica aggregates. So let's go to the first product, the JotaFloor filler, which can fill up to a width or depth of 3 millimeter, width and depth of 3 millimeter. It's a solvent-free, non-shrinking, non-slumping epoxy filler with a very high compressive strength. Just to show you a video as to how it's used, it's a 2-component product. And you can see here, after the primer has been applied, he's using the filler to fill all the cracks. Similarly, we have JotaFloor Filler Plus. This product is based on similar lines, but it can fill to a greater depth and greater width, 3 millimeter to 10 millimeter. This is also a solvent-free epoxy. It's non-shrinking, non-slumping. So what we mean by non-shrinking and non-slumping is when it is applied in its wet state, it stays in the same with the dry state. Usage areas. When it comes to car parks, we have typically residential car parks, public car parks like malls and public parking spaces, and commercial and residential buildings like hotels, office buildings, office towers. All these three are divided into three areas, namely the parking bays, the driveways, and the ramps. And some public spaces have something called the roof deck as well. If you take the industrial flooring, the factories, warehouses, loading areas, storage areas, production units, manufacturing areas, storage areas again, assembly units. Then you have the back of house, the support areas, corridors, and then you have typically chemical plants or chemical storages, laboratories, etc. And again, these two segments, the car parks and industrial floors, are further divided into light duty, medium duty, and heavy duty. As the images reflect, light duty would mean any area there where you use more of foot traffic. Medium duty would be cars, not very heavy traffic. And heavy duty would be hangars, um, heavy vehicles, trucks, buses, etc. Then we come to the classification of systems and the basic technologies that go into it. Although there are many types of technologies, there are water-based, emulsion, alkyd-based, epoxies, polyurethanes, and many other types. By and large, most aspects of floor coating revolve around epoxies and polyurethanes. Epoxies, because they are not cheap, but they're cost effective. They have good chemical resistance, good abrasion resistance, and good impact resistance. And that's why you find largely industrial floors have epoxies. Secondly, the bonding between epoxies and concrete is excellent. And that's why most floor coating systems have primers made of epoxies. Polyurethanes are generally used in situations like car parks because car parks require coatings that are more flexible, tensile, have elongation properties, have resistance to fuels. And polyurethanes are also adaptable, more suitable to low temperatures, particularly cold temperatures. And you will see polyurethanes are largely used in car park situations. All our products are tested by third-party labs, international labs, and we have a range of certificates for all properties that cover floor coatings, be it mechanical properties like compressive strength, be it MPI standards, be it food and beverage, or hygiene coatings. We have our products tested thoroughly by third-party international labs. Surface preparation. This is an important part of all floor coatings because the survival of all floor coatings depends largely on surface preparation. And although we don't directly control surface preparation, for us, our product's existence depends largely on surface preparation. And that's why we are focusing today on different types of surface preparation that is involved in application of our floor coatings. You can see on this pyramid here, we supply almost 80% of the whole pyramid, but 90% of all failure happens because of inadequate or poor surface preparation. So let's go into a small video where we are actually laying a floor. This is a power floated concrete floor, and you can see it's a very good quality floor that is being prepared. What you see is a helicopter travel in motion. And once this is cast, after it cures, you can see that to apply a coating directly on this would mean that there are chances of this floor coating that will be cast or be laid on the floor is going to be exposed to a lot of danger. That's why on the between the two images on the left and the right, what we are doing in surface preparation is basically creating a profile to anchor the whole floor coating process, a floor coating system. There are different ways. The most preferred method is the captive shot blasting method, where steel shots are fired at high intensity onto the substrate, thereby eroding at least a millimeter at an average of the top substrate, and at the same time creating a profile so that the coating system can anchor itself on the substrate. Now you can see very clearly as we go closer, there's a clear profile being created on the concrete substrate. This is called captive shot blast machine system, captive shot blasting method. The other is the diamond disc grinding method. Here, it's a similar method, but the functionality is quite different. What they are doing is using a diamond cutting disc that basically shaves off the profile of the concrete from the top, at the same time creating grooves or a profile to anchor the coating system. So it's basically cutting or shaving the top as well as opening up the pores. There are other methods, but these are the two most preferred methods in today's floor coating business. Jotun policy. What is our policy towards this business? Basically, we are quite unique compared with other suppliers. We are involved in surveying the concrete floor business, concrete floor substrate, selection of the material, helping in the application, and also surface preparation is something that we supervise directly. All applicators that we engage in to apply our products need to be trained by us. And then we certify each of these applicators so that the project owner or the client is satisfied that our products are being applied by the right people. Why do we do this? Because the risk involved in most floor coating projects is very high. The cost of the products are very high, and the prospect of closure of the premises is something that nobody wants to think of. That's why most stakeholders, architects, consultants are today more aware of the whole floor coating process. And that's why you have in some or in quite a few specification documents the clear definition of the supplier having trained persons and certified supplier having the right qualified people to do it. That even mentions the type of apparatus that is used in surface profiling or surface preparation. Now let's go into the products and its application. We will not cover all the products, obviously, because there is no time. We will select a few. Our range consists of a number of top coats, body coats or intermediate coats, and self-leveling type of products. The top coats are generally thin film. As you can see, we have epoxies, polyurethanes, high solid types, and also an alkyd-based product. The body coats are mid coats, can be used as top coats as well if it's not exposed to UV. And then we have self-leveling types, both polyurethane and epoxy. One of the unique aspects of Jotun is that all our products, or most of our products, let's say, are tintable at very short duration. And we thrive on providing tinting systems at all our retail outlets and in our factories that can tint a number of products, a number of colors at a very short span. We have what we call a multicolor industry tinting system, as you see this. These are installed in a lot of retail outlets across the markets. And plus, we have a range of colors that can be tinted on these systems at very short span. We would like to highlight to you JotaFloor Top Coat Eve. It's a premium top coat, solvent free, as you can see, with 100% volume solids. It is largely used in industrial floors. I'd like to show you a small video. It is normally applied by roller or can be applied by spray as well. JotaFlow Topcoat E is quite unique because it also has antimicrobial properties. It is normally applied between 100 and 200 microns. That means it's about 20% of a millimeter per coat. It has superior mechanical properties, provides hygiene. It is an environment-friendly product, so can be used in LEED projects and green building solution projects. One of the prestigious projects that we have established, we have executed this year is the Accident Evaluation Center, Salbuk. These are the detention or the prisons for the Oman government, for Royal Oman Police. There are 85 prison complexes across the whole country. It covers at least about 450,000 square meters of both wall protection and floor protection. Then we come to another product called JotaFlow Topcoat E Clear. This is basically a clear version because there are projects where they want to retain the original look of the concrete. It's a similar product, but without pigments. It is also 100% solids, antimicrobial, can be applied up to between 100 and 200 microns. It's a transparent coating. This is what it looks like when it's applied on a concrete floor. Basically, it offers protection, but gives you the original look of the concrete in itself. And if you look at a fully executed project, this is what it looks like. They want to retain the original look, but also offer the floor a decent level of protection. Now we come to the current market trends and what these specification involves. Let's come to car park solutions. Basically, a car park is divided into three areas: underground car parks, basements, and not exposed to the ultraviolet rays or the sunlight. Then you have the roof deck, which is separate from the basement, and these you generally see in large infrastructure projects like airports, metros, and some high-profile shopping malls. If you take a normal specification of a car park, you will find most specifications will be the same across all these areas. But what we have done is kind of value engineered these areas differently. For example, you don't require in a parking bay where the car comes and stands in a still position and there's not much movement, you don't require a very sophisticated specification. You can just go with 250 microns of primer and top coat. Similarly, for the driveway, you would, where the level of abrasion is quite high, you would require a different system. So here we have designed a system with primer, a glass flake membrane, 300 microns, and top coat. The ramps, a similar system, but we've increased the mid coat or the membrane by another 100 microns. And same with the top coat, we increase it by another additional coat. So we have three different systems for three different areas. This way, from the total budget for allocated to the car park, you could end up saving actually 30–40% instead of using one specification across the three areas of the car park. Then you have a fourth type, a new ASTM C957 compliant traffic deck system, which is, we will go into slight detail today. It's a polyurethane based system providing both waterproofing properties as well as high elongation and crack bridging ability. How we start these systems, we have a common primer, a solvent-free primer. We call it the solvent-free primer 150. And then we apply the membrane. The membrane is a glass flake high solids, normally applied between 300 microns to 400 microns, 300 microns on a driveway and 400 microns on the ramp. And these are environmentally friendly products, so they are LEED compliant. They can fit into any green building specification. I'd like to show you a video This is applied here by a airless spray, but it can also be applied by roller. What is unique about this concept? This concept has been adopted from our Scandinavian parent company, where this technology was used in ice-breaking ships' hulls. So these ships used to have this similar technology painted on the bow of the ship, where it is used to break the ice as they maneuver into the waters. The same technology was adapted to floor coatings, and you can see here these if you take a cross section of this is what it looks like. Basically, the glass flakes, which look like actually fish scales in a way, reinforced in an epoxy resin. So what happens is, when it's reinforced in this epoxy resin, it provides, once it cures, a brilliant layer which provides excellent chemical resistance, impact resistance, and abrasion resistance. Approximately, you have 100 layers of glass flakes in 1 millimeter of coating, DFT coating. So if you apply a 300 micron membrane on a car park, you have about 30 layers of reinforcement of the glass flakes. So it's a very robust kind of protection that you provide to the car park. It's quite unique to us. We have a history of number of years of experience with this. As you can see here in this next picture, this is a 500 micron coating used in a Caterpillar workshop. And you can see it's a huge equipment standing on a very bare minimum thickness coating of glass flake. Then we use a top coat, particularly on exposed areas, because the membrane is an epoxy. It cannot be exposed to UV, and all epoxies exposed to UV will generally choke over a period of time. So you have to use a polyurethane top coat, generally applied in 2 coats, and on ramps, sometimes we recommend 3 coats. This is a high solid, this is a medium solid 63% PU top coat, solid top coat called the polyurethane top coat Jotafloor. And this can be tinted in 165 colors. I'll show you a video where it's applied. Normally applied by roller, can be also applied by spray. And what the guy on the left is doing is actually broadcasting silica aggregates onto the substrate to create a non-slip profile in the top coat. Then you have a high solids version of the same thing, where it's 100%, 91% solids polyurethane, again tintable in 165 colors. This is a more advanced version. It's also aliphatic. That means it can be exposed to UV. It can be tinted in 165 colors, as I mentioned. It is applied between 75 to 80 microns per coat. And normally we recommend 2 top coats on normal areas and 3 top coats on ramps. This is one of the successful projects that we have done lately, the Riyadh Metro in Saudi Arabia, and the helipad for His Highness the Crown Prince. This is the Skyview Tower in Dubai, the Kempinski Palm Jumeirah in Dubai, the Abu Dhabi International Airport in Abu Dhabi, UAE, the Stefano Mall in Egypt, Cairo, in Alexandria, if I'm not mistaken. That was the glass flake system on car parks. Then we come to the new concept, or not relatively new, the liquid applied polyurethane coating system, largely used in modern day car parks. This is something which is about a trend in the last 5-6 years. As you can see, this picture is of the Chevrolet showroom and service center in Oman. This is a specification which clearly defines the use of this membrane, of elastomeric waterproofing membrane, which is high solids, and compliant with the specification called ASTM C957. And what this spec deals with, it basically says the membrane should have an elongation of greater than 90%, should be applied at minimum 500 microns or half a millimeter, bridge cracks in excess of 1.6 millimeter, and abrasion should be greater than, minimum, it should be the weight loss in the abrasion property should be less than 50 milligrams. That means every 1,000 cycles, the wearing of the coating should not exceed 50 milligrams. So you can see here, the specification clearly states that it has to comply with the ASTM C957 standard. What we offer here is a membrane called PU Universal. And if I just go back here, this is what the membrane looks like. It has a elongation property of 120. That means almost 20% above the standard in itself. It's 100% solids, provides a dust-free environment. And you can see here, it has 100% resistance to water, elongation of 120%, 119%, abrasion of 21.3. That means almost double the standard that is required, that is specified in the ASTM C957 standard. Compressive strength of 89 Newton, almost 3 times concrete. Crack bridging ability of 3.6 and 2.17, depending on the DFT. Impact, heat resistance, tear strength. And I would like to show you a video of a real-time application of this product on Abu Dhabi's New York University. So they have applied the primer, now they are applying the membrane, the PU Universal. This is being applied at 500 microns. And then this is a project we did for the Al Futtaim group, the city center malls in Oman, where they wanted to test our product to see its waterproofing ability. This is a 72-hour test done as per ASTM D5957 standard to see how it has water prevention or water penetration properties. Some of the recently executed projects, the SKICO or the Saudi Electric Company in Riyadh, these are 4 building blocks, and below which is this massive car park which covers all these areas. Doha Festival City in Qatar, the Hamad Hospital in Qatar, Maktoum International Airport, Dubai World Trade Center and Ibis Hotel, Muscat International Airport, Reem Mall in Abu Dhabi. This is perhaps going to be the largest mall when it's completed in this part of the world as of date. Then we come to the commercial buildings and car park coating systems, plus back of house areas in industrial flooring. We have a product called EPC 300. It's an epoxy coating, which can be applied at an average of 300 microns, the recommended thickness. And one of the unique features of this product is that it is solvent free, of course, but it can be applied without the use of a primer, provided the substrate is well prepared. And you can see in this video, he's applying it directly on concrete. It also has antifungal and antimicrobial properties. It is LEED compliant, can be used in green building solutions as well. One of the famous projects that we used this was the car parks in Abdali Mall in Jordan. This is the largest mall they have there. The Soba Sapphire building, Dubai. This is again used in a car park. The Al Rayyan Stadium in Qatar, which is going to be used for the soccer World Cup in the 2022. Harley Davidson showroom. That was EPC 300. Then we come to the next topic, that is industrial floors. Industrial floors have a different kind of need. These are projects that will involve large storage areas, loading areas, unloading areas, manufacturing units, assembly units, corridors, chemical plants, laboratories. So the need is quite different. Generally, the coatings with high impact resistance, high chemical resistance, high abrasion resistance, and normally applied at a DFT or a dry film thickness of 3 millimeter. So we have a very unique product here. It's solvent free with nearly 100% solids, barrier to chlorides and moisture, antimicrobial growth, and applied up to between 1.5 millimeter to 5 millimeter. And it has an abrasion resistance of only 30 milligrams per 1,000 cycles when it's measured under the CS17 category of abrasion resistance, ASTM D 4060 standard. This is a video how it's applied. These are heavily filled products. So we mix them, pour them on the floor, and then use a trowel or a rake to spread it. The wet film thickness, that means the wet coating and the dry coating have the same DFT because it's solvent free and nothing evaporates from the coating. Here we are applying it after the primer. You can see the primer is applied and then it's filled with a filler to level the surface, and then we apply the coating. And it has a compressive strength of 74 Newton, which is almost 2.5 times the normal compressive strength of concrete. A shore hardness D of 75, which is extremely high. It's antibacterial and chemical resistance certified. These are some of the projects that we have done. I would like to show you General Motors Saudi Arabia. This is the Tesla Dubai project, which we did very much in the early part of this year. This is the Al Maktoum Hamdan Sports Complex in Dubai, all the corridors and internal areas. This is the Jeep facility or Jeep service center and retail facilities in Oman, where it was applied at 3 millimeter thickness. Washman Laundry. This is the large scale laundry which does bulk cleaning and dry cleaning services. This is a hangar for Sky Dubai Aviation. So this product is largely used in very high impact areas. So hangars are a very preferred area where this can be used. Then we come to another product that we have just launched. It's called the process industry for food and beverage, pharmaceuticals and cosmetics. This is a product made of polyurethane binders, and it is certified based on hazard analysis critical control process, which is in short called HASP. It's a worldwide certification program, which is essential for high hygiene sanitary areas like food and beverage, pharmaceuticals, alcohol production, where a high degree of hygiene is required. This is a seamless self-smoothing solvent-free polyurethane, and it's a hybrid technology with antimicrobial features in it. Just show you a video. It's also applied similar to the epoxy, which you saw in the earlier video. We mix 4 components, pour it on the floor, and it's applied by a rake and back rolled by a dry roller. This is a very robust product, usually used in food and beverage, kitchens, pharmaceuticals, cosmetics, electronics, confectionery, and textile. It is antibacterial, seamless, matte finish, solvent-free, high impact, non-tainting or non-staining, withstands very high abrasion, and it can resist a spectrum of huge range of chemicals, and it can also be exposed to steam cleaning on a regular basis. It has a number of unique features: compressive, flexural, tensile, impact, water permeability, slip resistance, shore hardness, abrasion, chemical resistance, temperature resistance, and its volatile organic compound is only 69 grams. That means anything below 100 is low VOC compliant. And this is a video of how the coving is done on a corner. This is the skirting, or as you call it, and the edges of the perimeter of the walls, so that there is no contamination on the, or any growth of fungus or bacteria at the periphery of the floors. So it makes the floor a seamless entity between the floor and the edge of the wall. So some reputed project references over the years: Nissan in Saudi Arabia, Toyota in Oman, some soccer stadiums, RCA Stadium in C. Boman. This is the Dubai Metro, covering a 50-kilometer, the original metro, the first phase, 50-kilometer in length. This is Jotafloor PU top coat, which is exposed here. You can see very clearly. This is Chevrolet in Kuwait. That was the floor coating part. Of course, we have a range that is much beyond this, but because of the time constraint, we had to make our presentation today within the 1 hour period. So I hope we are able to deliver the message that we are a comprehensive solution provider when it comes to intumescent or steel fire protection, as well as floor coatings. These are two components of the infrastructure concept, which is very, very important these days. And most of these infrastructure projects combine these two elements quite significantly. Having said that, I would like to conclude my presentation, and we are willing to engage you to ask us any questions related to the two topics. My colleague John Brown and me will take your questions as and when they come.
Okay, Niru, your mic is off.
Yes.
Okay, and Mr. John. Okay, we have plenty of questions. I will start right away. Okay, the first question we had is from Alice, and it was, Jute materials is environmental and sustainable material?
Yeah, most of the products are certified for sustainable buildings. They're LEED compliant, so we certify them. We get them tested at third-party labs, mostly in Sweden and Singapore. So we have a range that comply with sustainability and LEED projects, if that is the right answer you're looking for.
Yes, and I believe in the first session we had with your colleague Hafid, we had, it was all about actually sustainable products and LEED accreditation and certification for the products. So everyone come back to the YouTube and see it. Okay, the second question we had is from Ahmed Ramadan. Can we apply epoxy coat on ceramic or tiles?
Yes, you can apply on ceramic floors. We have done a few, in fact, one of the pictures on my presentation was actually one project that we have done on ceramic, but it requires a different degree of surface preparation, because first we have to ensure this, the tiles itself are stable, because generally when people want to redo a ceramic tile floor, they want to rectify the weaknesses that exist in the ceramic tiles itself. So we have to first ensure the ceramic tiles are sound enough or they're stable enough to carry out the floor coating process. So to do that, we need to first ensure the tiles are anchored properly. If not, then you have to make sure you do the necessary repairs and provide the substantial firm footing of these tiles itself. Then you create the right kind of profile on the ceramic tiles, and a very specialized kind of tool is used, and then you can apply a coating
So
system.
this
Generally,
question,
you have to apply a self-leveling type epoxy type coating. You can't apply thin films, because at the joints you have a depression, and these depressions have to be covered. So you generally need quite high DFT systems to cover ceramic tiles. But we can do.
Okay, so next question is from Atif. What are your solutions for heritage buildings?
You mean external facades, or you're talking about?
Let's say the protection for heritage buildings. I think the part of Mr. John and Mr. Atif is still with us. He can clarify.
I mean, if you're talking about what we do with fire protection on heritage buildings, is it's retrofitted. It's fitted after the building's been painted, in which case we have to grind down the steel, do the surface preparation, and then fit the fire protection afterwards. But we have done them. It's just very expensive to do exposed steel on heritage buildings.
For heritage buildings, okay.
Yep.
Okay, next question. What is the difference between solvent and water-based and epoxy-based cementitious fireproof paint? Who's responsible to choose which kind of products to use?
Okay, to put it simply, cementitious coatings are used behind linings. Epoxy and water-based intermittent coatings are used where steel's exposed. Water-based is used in environments up to C3, which is internal environments. And if it's a more corrosive environment, you will use an epoxy. The only areas we've seen epoxy used is on external surfaces, which are close to the seaside. So epoxy for anti-corrosion, water-based for exposed steel, cementitious for steel that's not exposed.
Okay, we used during the last 3 sessions we had with your colleagues that they share a website or a link or a guideline where we can have more information about the products. I mean, technically, or to learn more about this question, how to use such product or etc. project, but and different types. Do you have a certain link, or we can find it somewhere in Jotun websites too?
We'll send you a link
Okay,
to the
perfect.
individual section. No problem.
Okay, thank you. So far, these are the questions that we had. We'll just wait 1 or 2 minutes. If anyone have more questions, please send it now so we can wrap up. And thank you for the presentation, Mr. John and Niru. Yeah.
No problem.
Welcome.
Our pleasure.
A pleasure.
Okay, I think we can wrap up. Oh, no, we just had a question. No, actually, it's not a question, it's a comment. Yes, it's a question for our colleagues for all the ArchiNet talks. In August, it's been switched from 8 to 9 p.m. instead of 9 to 10 p.m. So all the coming talks have the same time from 8 to 9 p.m. Anyhow, anyone who missed it, they can watch it on the YouTube. Okay, Mr. Nero, Mr. John, I think
Thank you.
we have all the questions. Thank you again for this presentation, and thanks for Jotun. Thanks for everyone who attended with us to talk.
Thank you.
Thank you.
Thank you again. Thank you.
Good night.
Take care.